Yes.
So before we get started today, I think we're all a little unsure about the requirements around Java docs on our assignments. Could we go over that and maybe clarify what
Ah,
we're looking for?
okay, yeah, thanks, yeah, because basically, um, every method needs to have a Java doc.
Also setter and getter?
Well, the setters and getter, yeah, setter and getter, you can just use the generated one. That's
Okay, and toString also?
the,
The
yeah,
toString?
now, toString is, yeah, not absolutely necessary. But if you, especially if you have a method that does something, then you need to say what it does. So in the last assignment, the play method needed a Java doc because, yeah, I guess I wasn't clear enough on that. Although, I mean, some of you did, but a number of you didn't. So, yeah.
How are you pulling up the Java docs? Like, how are you looking at them? Are you just looking?
Oh, it's in the code, yeah.
Okay.
I mean, okay, so what needs to go in there? I mean, kind of enough, ideally, enough so that if somebody were kind of reading it, they would know what that method was supposed to do, even without looking at the code. Now, at one extreme is kind of basically either nothing or just saying, okay, like the play method. The play, this plays the game. Okay, so that's pretty minimal. That doesn't kind of describe it. At the other end is kind of duplicating the code and going, I mean, that's too extreme. So it's like, can you basically describe it? It would be something like, rolls the dice, determines, what the appropriate actions are, and plays the point out to the end if that's what comes up, something like that. In other words, a description of what it's supposed to do. Does that now? I mean, as you've seen in some of the, especially in the ones that are in the Java standard library, they'll have like a tutorial on how to use this thing. So now that's a little extreme for this, but the idea is that if somebody sees what the method is supposed to do, then they don't have to kind of delve into the code to at least know what that method does. Okay, so what is that? What's the use of that? Well, if you're going to use a method for a task and you want to know, okay, does this method do the task that I want it to do? Then if you don't have the source, one way is to kind of look at the source code, but it's like, a better way would be if I look at the Java doc and this method claims to be doing this particular task, then I can use that method to do the task if it does what I want it to, and it's been implemented correctly. Okay, does that, and it wasn't, so is that, I guess I wasn't clear enough in terms of what I wanted on that, but is it clear now, I hope?
Just enough that someone would be able to use it without having to go through the code.
Yeah, not and again, within reason. I mean, in other words, well, for example, like you notice that sometimes I'll use, let's see, what was the last one? When I use the arrays copy of to do some of that stuff. If you remember when we were kind of adding something, storing it in an array, and then expanding the array if necessary, and I was using that method copy of range from arrays. I've never looked at the source code for that, but when I look at the Java doc, it was important to understand a couple things about that were in the Java doc. First of all, kind of what it did. It would take an array, make a copy of it in a particular range, one of the key things to know about that was the range inclusive or exclusive? We saw that also in the random class. There was like kind of the next int with kind of two values, a lower and an upper. And it turned out the lower was inclusive and the upper one was exclusive. That's important to know, because if you don't know that, then you're going to kind of misuse it. But that was in the Java doc. And so you read that, you get the key information for how to use the method. And the thing is that when, kind of in the modern development environment, when you're writing a program, why are you writing a program? Because you want it to do something that hasn't been done before in that particular way. In the process of that, there are certain tasks that need to get done. Many of those tasks are met by the language itself. So if I want to add two things together, I use the language to add two numbers together. But a lot of tasks, you have a choice of either rolling your own or using something that somebody else has done. And there, it's almost always more effective to use a method or a class that somebody else has developed rather than rolling your own for that task. Why? Because if it's from just say a trusted source, such as the Java Standard Library or a library that you trust for doing some other task, then the chances are that they have kind of stress tested this thing. And so instead of kind of reinventing the wheel, you just kind of use a wheel that somebody else has made. That's why, just a small example is like in the book, when they wanted to generate a range of random values, if you remember, they only used the upper bound one and then added their thing to it. To me, that's more fragile than what I was showing to you, where you use the other method that basically does that under the hood, because every time every time you're kind of doing something else, that was kind of a minor thing, but there's a chance that it would kind of screw up. In other words, doing it just with one single call to the next int with the lower and the upper is more robust, more safe than kind of doing something else to it, as simple as that was. So that's the why, and to make a short answer long, that's the why of JavaDoc. So it's like the kind of using things that other people have built and knowing how to use them. So and I have to say, like for me, that was a significant mind shift, as it were, because coming from the Fortran era, where pretty much everything you had to roll your own. It was kind of it's like when confronted with a task, a lot of programmers will say, okay, well, here's a task, I'm going to implement this, and by task, I mean, here's something that needs to be done as part of the bigger program. And the tendency is to kind of do it yourself, and that's what I guess what I'm encouraging is to kind of use what somebody else has already done. Now, having said all that, today I'm going to kind of delve into. Let's see, are we recording? I hope. Okay. Actually, where are we? There. Okay. All right. So this shape example in the class is it's a very nice example. There are things that the author is doing that I'm, of course, going to take a little issue with and do a little differently. But what I want to do is I want to walk you through at least a partial implementation of what this shapes thing is about, mainly to see some concrete, a concrete implementation of how to use abstract classes and what's that about. In the meantime, also look at this inheritance thing and understand some issues about kind of what's there and what's not there, because there's some kind of counterintuitive things going on. And then in the process, if I can get to it today, in implementing these sort of shape things rather than keeping them abstract, we're going to at least kind of show what they look like. Okay, so how to define an abstract class. Again, we've done a little bit of that, but we'll kind of basically do it again. And then defining abstract and concrete subclasses. We haven't gotten to that. Here's one little gotcha on the whole thing, and that's to understand that as we're using them here, instance variables are going to be private as we use them here. We're going to skip the projected stuff for now. We may circle back to it. If I don't circle back to it this quarter, we're going to circle back to it next quarter. But for this quarter, for this level of programming, just make everything, all instance variables, private for now. Okay, so that with the understanding that there is a use for protected, but that's going to be later on. Instance variables private. Anything else is kind of a mortal sin. Certainly, public instance variables are a mortal sin no matter what. Okay, so right. Okay, so we've taken a little bit of a peek at this, and this shape class is going to be the base class for all of the other things. And how do you come up with something like this? Well, when you're designing one of these, when you're sitting down and kind of figuring out where things go, it can be an iterative process. One of the things that I do is a lot of times what I'll wind up doing is I'll wind up designing or kind of thinking of a bunch of different types of classes. So here, ultimately, we're going to have we want to have different shapes and represent them. So what are the different kinds of shapes? Circles, ovals, squares, rectangles, triangles, ultimately arbitrary polygons. Well, not going to get to the polygon thing. Maybe we will. So those are kind of the different types of things, and then so what the thought process is what are the things that they all have in common? And anything that they have in common, you want to make a property of a base class. So in this case, what the designer has done is said every shape is going to have two pieces of data, and they will often have more, but they're all going to have a location, which is going to be where they are on the screen, and then they're going to have, and then he made it an array of dimensions, and what those dimensions are going to be, are for so for one-dimensional shapes, they're going to be shapes for which one parameter is enough to specify. So specifically, if I have a circle and I want to know how big the circle is, I just need one number, say the radius. If I have a square, I just need one number, the length of the sides. But if I have a rectangle, I need two pieces of data. I need the width and the length because they're going to be different. So that was kind of the differentiation that the author did. So we're going to have these one-dimensional things that are, which a little bit of a misnomer. Maybe it's the author is from New Zealand, so maybe it's a language thing. They're all two-dimensional because we're going to, but okay. So those are these are the common pieces of data that everything is going to have. And one indication of something to put there is that if you're thinking about how to create each one of these different types of things, what do they all have in common? So what they all have in common would be like where they are, the location, and then the dimensions, if you will. So for the one-dimensional ones, they have that one number that tells you how big it is, and then for the two ones, you need the two numbers. And if I were representing three-dimensional things, then I would need three numbers, height, width, and depth. Okay, so now keeping in mind that the dimensions might be different for the other ones, when I create one of these things, I need to at least kind of give it give it where it's going to be, and so I'm going to have a setter and a getter for those, and a setter and a getter for my other ones. Generally, having a setter and a getter for your instance variables is usually the default, but you also want to think of, okay, do I want to allow somebody else to set these things? And do I want to allow someone else to kind of peek at them? We've seen examples of both. Now, the other thing is that here are two methods that every shape, every one of these things is going to have to be able to tell me. One of them is tell me what your area is, and the other one is a method called draw, and we're going to say in other words, how do I draw this thing on the screen? And when I'll probably won't be tomorrow that I actually am able to draw them. But okay, now these are in italics, which indicates in this context that they are defined to be abstract. Okay, so what's the thing about that? If I have an object reference variable that's been declared to be a shape, then it can, knowing nothing more about it, it will be able to invoke any of these methods, and the compiler will let it through. So if I have a variable that's been declared to be a shape and I've managed to instantiate it, then I can get the area of the thing, and I can draw it on the screen by invoking these methods. They're abstract because while the setters and the getters are ones that I can implement, each particular shape is going to have a different way of computing the area and a different logic for drawing it on the screen. We'll see that. So if there is a common behavior that you want all of these things to have, but you don't know how to do it, in other words, you need to know a specific, a concrete example of it, an instance of it, in order to implement that, then you can still define the method but make it abstract, meaning that you'll be able to call it, but you won't know how to do it if in the shape class itself. Specifically, if I have a circle or a rectangle and I say what's the area, then I'm going to compute those completely differently. Just like a rectangle or an oval or a triangle will all have different equations for getting the area. Likewise, drawing them, obviously, if I go to draw a circle, I don't want it to look like something else. Okay, so now how is this implemented? Well, basically, just take, So the two instance variables defined here, I just kind of copy them down. Here's the shape, the shape constructor, and in fact, here, So the constructor, I set the location, and, okay, set the location, get the location, that's fine. Here's how we define the abstract method. So here's the abstract method draw, and it uses this thing called graphics. We'll get into that, and then the get area. Now, okay. So now here, this is something that unfortunately I think the book isn't so good about. The cardinal rule is when you have a setter or a getter for an array, then you always want to return a copy of it. So if you're returning the entire array, then always put a clone on it. And likewise with the setter. If I'm setting this, because to not do this violates encapsulation. Okay, so, and now notice that I have not put JavaDoc here yet because it's a work in progress. So that, I want to make sure that I am, and I hope you notice that at least all the code that I do present eventually has, at least for the components, have JavaDoc on them. The main classes, it's less important to go into specifics, but less. Okay. Abstract subclasses. So here's the inheritance thing. So what this UML, and this is kind of UML light, kind of adapted for Java-like things. The book's syntax for these is closer to the official UML, but for me, I prefer to use something that's a little more connected to the Java stuff. Okay, so now one-dimensional shape and two-dimensional shape. So that we're going to distinguish those two. And so the constructor for one-dimensional shape, I need to give it a point 2D because the superclass constructor requires a point 2D. Otherwise, we get that weird error. And I also need to say, all right, this is the dimension for that. And I'm going to add an extra setter and getter for that. But what I'm going to do is I'm going to use this to actually get these values. In other words, when I set the dimension, it actually sets the array in the superclass, and we'll see how to do that. Similarly, now I'm not sure if for me a two-dimensional shape, the important quantities are width and height. So I have added a setter and getter for the width and the height, and just as with the one-dimensional shape, those are going to be just grabbed from the dimension superclass. So I think I started this last time. So here's how we implement this subclass thing. Oops. So public abstract, because it's still abstract, extend shape. And if I leave the abstract off, which in NetBeans it doesn't let me do that automatically. In fact, here what's interesting, NetBeans is very good about this. So let's say if this is what I would get when I created the new one. And then I get red squigglies, and it says it's not abstract and doesn't blah, blah, blah. And again, these little light bulb ideas are often very useful. So my two choices are implement all abstract methods. I don't want to do that because this class isn't concrete yet, or I can simply make it abstract. And so when I select that, then it actually does it for me. So generally, sort of picking something is much more reliable than typing. So, all right, so it's still giving me red squiggly. So what is the problem? Again, now this is that strange error. It says constructor shape and class shape cannot be applied to given types. Required point 2D, found no arguments. You say, what the heck? What the heck does this message mean? And it means that Java has inserted the super call with no arguments. And what the problem is? The problem is there is no super constructor with no arguments. The only constructor is one with a shape. So does NetBeans have a suggestion? It says add a constructor. And so if I add the constructor, then it does it for me. Okay, so that's kind of how to do it in NetBeans. So now there's this additional setter and getter. So a singular dimension. So I'm going to return okay, so I'm going to return get dimensions of the the zeroth index, because in these there's only going to be one value there. And then here now I want to set dimensions, and okay, so now this isn't going to work very well. Notice that dimensions has private access, so oops, dimension. Okay, so how do you, let's say, oops, it wants another parenthesis. Oops, no, it wants, this should be a curly, yeah. Okay, so now here's here I've fat fingered this. It's not the worst thing in the world, but it's like, okay, that's a little annoying. So here's a task that you sometimes have to do, and this has happened to me where it's like I'll have a variable and I want to change the name of the variable, but that I've used that variable a dozen times in the class. So what do you do? Well, if you're doing it by hand, I have to go change the name of the variable in one place and then find all the other places and change it there. Or I can use refactor. And I say refactor, change name. In this case, instead of dimension, I want dimension. And when I do that, it changes it everywhere. So refactor is just really great for that. Okay, so that's my one-dimensional shape. Well, what about the two-dimensional shapes? Well, Chad, I'm going to drill down on this side of the class hierarchy, and kind of at least two of these things are, I have a circle and a square. So let's do the circle first. So now, oops, these should not be. I'll have to fix that. These are now concrete classes. So this should not be. Those shouldn't be in italics. So this is going to be implemented. So how do I make it concrete? Well, at the very minimum, I need to implement all of the abstract methods. So, okay, so the circle, I'm going to need, I have a constructor, and then I'm going to have these kind of draw things here. So let's see how that works. Okay, circle. Now for the superclass, I can browse, and here's my one-dimensional shape. I can select that, and there's all this garbage here. Okay, so here it's not abstract and does not override abstract method. Now let's see, whenever you get the red squiggly, look for the little light bulb suggestion. All right, so I could either make it abstract, but now I'm actually implementing this, so let's implement all abstract methods. And then let's see, it still says No constructor, so let's add the constructor. Okay, so now the red squigglies have gone away, but I still need dimension. And then wait, my one-dimensional, oops. Oh, this. I forgot to do this. Okay. And then, you know, NetBeans kind of complains about overridable method. That's it being kind of a worrywart. So here it's like, actually the easiest thing is to just delete the whole thing and have it regenerated. And we add a constructor, and now things are all cool. All right, so now let's let's do the easy one, get the area. Okay, what's the area of a circle? Pi r square, right? Or as they say, no, pi r round, cornbread r square. Now here, and here's where the okay, so here's, notice I said pi, can't find the symbol, can't find the simple. Let's see, add import for, okay. And it makes the code kind of cleaner when I have these kinds of things. And then notice when we're importing, okay, what is this? We can actually, let's navigate to the declaration to see what that is. So they have declared a public static final pi, and then that's the value they use. So that's, when it comes to using constants like that, always, if the language itself or the library, the standard library has that value, use that. In other words, wherever you're using pi, use the pi in the library. If there's a number that you're going to be using throughout your program, then define one of these yourself, and that way you can always have it available. If it's public static final, then everybody can see it. Nobody can change it because it's final. And the other thing is that let's say that you had a constant like that you were kind of using, and then at some point you decided, well, I want to have a few more decimal places in it. I want to have it be a little bit more accurate. Well, if you've just typed that number in a dozen places in your program, then you have to go everywhere and find it. If you've done this, then you just have to change it in one place. Okay, so now here's the thing about, and we're gonna, well, maybe I'll, this graphics thing has, this is how we can kind of draw things, and it actually has something, well, it doesn't have a fill circle, but it has something called a fill oval. And what this is going to do is for one of these graphics objects, which is one of the graphics contexts that the Java uses to draw things, this will fill an oval at a particular place. So now, I'm going to get the location where I am. Now, the book uses a kind of a more ancient class called just point without the point 2D. And the problem there is that if I want to get the x and y coordinates of that, then they're using instance variables, which are public, which is kind of a no-no. Why is that? Because that was implemented in kind of a crash way by people who weren't totally on board with the object-oriented stuff. So the first two arguments are going to be the x and y location on the screen. Now, here they have a getter for that. Now, the problem is that the getters are actually doubles, and that turns out to be a useful thing, but for this we have to cast it to an int. Not a problem. And then the second two are going to be now since we're filling an oval, to make it a circle, I just give it the same two values. So what this will do is this is going to create a filled oval and display it on the screen. Okay, now what I like to do is as soon as now that we have a concrete class that we have fully, hopefully implemented, I mean, this is all there is to that. Like, I have the two methods and the constructor. That's all the design was. Now, maybe the design is flaky. If that's the case, I may have to kind of go back and fix the design. But now that I have a concrete class, then I want to test it. So the idea is testing, it's like, like voting, vote early, vote often. So let's, now here's the thing is that let's, the book kind of also messes this up a little bit. What I'm going to do is I'm going to create something called a draw panel, which is going to extend something called a JPanel. This, in kind of implementing this, this is kind of a peek ahead to something we're going to do much later in the course, but this is just how to kind of do these kinds of things. So for this draw panel, what I'm going to do is give it a bunch of shapes . Let's kind of do the same thing on this, and then okay, I'm going to use the same pattern I had before. Where I'm going to keep track of these, and then when I add a shape, I'm going to say if the number of shapes is equal to the shape's length, then I'm going to just kind of kind of double it, and then now I can okay, this is the same pattern that I've done before, and then the key method here is something called paint component. And we need to fix the imports there. And so what am I going to do? I'm going to buzz down my shape. And then for each one, I'm going to I'm going to just draw it. And this is an override here. And let's see, what else did I need to do? Okay, so that's basically all that I. But what I have to do now is let's see, did I? All right, so now how do we put this together? Okay. What we're going to do is we're going to define something called a J-frame. J-frame is the swing window that basically, well, here, NetBeans, I believe, is written in Swing. So this whole window in NetBeans is actually something called a J-frame. So what I'm going to do is I'm going to define this frame. And I'm going to give it a title. Now, there's one little thing I need to do is I need to set the default close operation. And let's add import. That just makes sure that now I'm going to create one of these draw panel things. And then I need to get the content pane and add that to this. So I mean, so what I'm doing is this JFrame thing is a very complex deal, but now I need to set its dimensions because by default it's like 0 by 0. I can set the size. Oops. Oh, let's make it 500 by, let's make it 700 by 500 pixels. And set the location. Oh, let's give it like 200 by 200. There, okay, so that's just sort of setting up the size of the thing. And now I'm going to actually create one of these circle guys. So let's see. Let's make it 150 pixels there. Now I need to give it one of these Point2D things. Now Point2D, it turns out, is actually an abstract class, but they have this weird thing. I've got to give it a new one here. Okay, so let's, where should we put it? Let's put it, at 200 pixels there. And then add it to the, add a shape. Now, there's kind of a tricky thing about running graphical programs. We actually have to there's an interface, and you read about interfaces, but we're deferring them a little bit. There's an interface called Runnable that we're going to implement, and implements runnable. And now if we implement all abstract classes, what that does is that creates a method called run. And all we're going to do with run is we're going to set it visible. And so there's a there's a method called invoke later. All right, so now all this we're going to kind of go into in more detail later, but the bottom line here is that when we run the thing, we actually get our circle. Okay, so now the circle is actually working. All right, so the point here is that before I want to kind of implement any more, I want to make sure that I've made one and it actually kind of works. Okay, so I've made one and it seems to work. I mean, I could do more testing and make sure this is exactly what I wanted, but you know. And actually one of the things that brings up, notice that all the colors are going to be the default one, which is black in this case. So, well, what if I want different colors? Okay, so just as an exercise, or just think about where you would want to put if there were a color. If I want to have different colors for all these, where would I put it? I could give each one its own variable called color, but there's a better way. I think you know which one it is. Okay, so just to kind of put a point out. Okay, well, what was the point of this? If I run this again, okay, there it is. Now if I close it, notice what's happened, what hasn't happened. The program is still running. It just, the window has disappeared. But the program is still running. So, but I have no way to kind of, I have to kind of nuke it, basically. So why, so this says, oh, instead of the default, which is just to hide the thing when I make it hidden, actually exit, do a full exit. Let's just make sure that's also working. Okay. All right. Okay, so the idea is, kind of as soon as you can actually have a running program that does something to test what you've done, do that. And don't take another step until you verify that what you've done actually works. Because, tomorrow I'll kind of finish this up and then show you some other things about that, because the overall lesson is this class hierarchy, abstract methods, how that's going. And the fact that the one thing I want to point out here is that these instance variables up here in shape, they exist in all these places, but because they are private, I don't have access to them. I cannot say location. I have to say get location. I have to use the getter. So even, this is what's a little confusing. Each of these classes, each of these instances has these instance variables, but I cannot access them because private means only in the class that it's defined. So I can't say location down here. I had to say, where was it? Here, I had to say get location. I could not say location. So if I try to do that, it says, oh, location has private access in shape. Can't get there. Okay. So see you tomorrow. Stay dry.